Hey everyone, welcome back. Are you ready to take a deep dive into the world of LLMs? You know, those AI systems that can write pretty much anything these days.
Amazing how far they've come.
Yeah, from chatbots to story writers to, I don't know, maybe even replacing us podcast hosts one day. Who knows?
I don't think we're quite there yet, but it's certainly an interesting thought.
Right. But jokes aside, you sent over this research paper and wow, it really gets into the nitty-gritty of how these LLMs are trained and how they're being refined.
Yeah, it goes way beyond just the hype of what LLMs can do. It's really about how researchers are trying to make them better thinkers, more reliable, more useful for all sorts of real-world tasks.
Okay, so let's break it down. The paper starts by reminding us that at their core, LLMs are essentially built on predicting the next word in a sequence, right? Like, they're amazing mimics, but their reasoning isn't exactly like ours.
Yeah, exactly. Think of it like this. Humans use logic and facts, like building a house brick by brick. LLMs, on the other hand, they're more like these master puzzle solvers, incredible at finding patterns in data, but their logic is more based on statistics than hard and fast rules.
So an LLM might write a beautiful poem, but then struggle to summarize a complex scientific paper logically.
You got it. And that's where all these post-training techniques come in. Researchers are exploring all sorts of things like fine-tuning and reinforcement learning to make LLMs more reliable, less prone to going off on tangents, and better at following our instructions.
Right. So fine-tuning, that sounds like giving an LLM specialized training, right? Like taking a general language whiz and turning them into a legal expert or a top-notch translator or something like that.
Exactly. But there's a catch. It's like sending someone to a super intensive course. They might become amazing at that one thing, but they could also forget some of their broader skills.
So it's a trade-off, right?
Yeah.
You gain expertise in one area, but it might come at the cost of broader knowledge.
Yeah, and the paper actually calls this overfitting, where the model becomes so specialized, it loses some of its flexibility to handle new situations.
Makes sense, but here's where it gets really interesting, Femi. Reinforcement learning. Now, isn't that how we train dogs?
It is.
Okay, so walk me through this.
Imagine teaching a dog a new trick. You reward them with a treat when they do it right. Well, LLMs learn in a similar way. They get rewarded for generating text that's accurate, helpful, and follows our instructions.
So instead of a treat, the LLM gets a virtual pat on the head for being a good language model. That's pretty wild. Now, the paper also talks about scaling LLMs, and I'll admit, at first I thought that just meant making them bigger, adding more parameters.
It's a bit more nuanced than that. Think of it like training an athlete. You're not just making them bulk up. You're refining their technique, their strategy, helping them use their energy more effectively. With LLMs, it's about optimizing their performance, their efficiency, not just throwing more data at them.
So instead of just making the LLM bigger, we're teaching it to think smarter.
Exactly. And that leads us to techniques like chain of thought, where the LLM is encouraged to break down complex problems into smaller, more manageable steps.
Okay, yeah, that makes sense. Like if I'm struggling with a tough problem, I try to break it down into smaller parts too. But wouldn't that make the LLM slower? Like all that extra thinking?
It's a good question, and it can sometimes lead to longer processing times. The paper talks about that. It's about finding that sweet spot between, brilliance and speed.
A brilliant but slow LLM isn't very helpful in the real world.
Exactly. So we've got fine-tuning, reinforcement learning, and scaling, all these different approaches to making LLMs better thinkers. But the paper really dives into how reinforcement learning is actually integrated into LLMs. It's a multi-step process, right?
Yeah. Lay it on me. What are the steps?
Well, think of it like a 3-stage training program. First, you have supervised fine-tuning. It's like giving the LLM a crash course using human-crafted examples. We show it the style, the format, the level of detail we want for, whatever task we're training it for.
So it's like giving the LLM a style guide or like a set of best practices.
Yeah, that's a good way to put it. Then you have reward model training.
Okay, what's that?
Imagine you're training a food critic. You give them a bunch of dishes and they rate them. That's basically what we do with LLMs. We get outputs from the fine-tuned model and then have humans rate them, based on their preferences.
So the reward model learns what we humans like and dislike. It becomes like a stand-in for our judgment.
Exactly. And that brings us to the final stage. Reinforcement learning, fine-tuning.
Okay, bring it all together for me.
This is where it all comes together. The LLM is further fine-tuned, but now it's guided by that reward model. It learns to generate text that would earn a high score from this model. which reflects, what we find preferable.
So it's indirectly learning what we want by trying to please its AI teacher. That's fascinating. Now, the paper also gets into different types of reward models, right?
Right. It does.
Break those down for me.
You can think of it as two main approaches, explicit and implicit. Explicit reward modeling is like giving the LLM a very clear rubric. We define specific rules or use human annotations to guide it. It's very direct.
So we're explicitly telling the LLM what we want. What about implicit?
Implicit reward modeling is more, I guess you could say, subtle. It's like figuring out what people like based on how they behave. Think about those E's.
Huh?
You might also like suggestions online. They're based on what other people have clicked on or purchased.
So with LLMs, we might look at things like upvotes or how long someone spends reading a piece of text to kind of infer what's considered good. But wouldn't that be problematic? What if people are clicking on things that are, sensationalized or misleading?
That's a great point. Implicit reward modeling can be tricky because the LLM might learn to, game the system, producing outputs that get clicks, even if they're not actually high quality or accurate.
So it's a balancing act, right? You want to use implicit rewards because they're scalable, but you also have to make sure the LLM isn't being incentivized to prioritize engagement over accuracy.
Exactly. Designing effective reward functions, that's a major challenge for researchers.
Now, once we have this reward model in place, how do researchers actually use it? Like, how do they shape the LLM's decision-making?
That's where policy optimization comes in.
Yeah.
Think of it like this. The LLM has a certain policy, which is basically its strategy for generating text. Policy optimization is all about using that reward model to kind of nudge the LLM's policy in the right direction, encouraging it to produce responses that are more likely to get those high rewards.
So we're not directly controlling the LLM, but we're using this reward system to guide its learning, to kind of shape its behavior over time.
Exactly. And there are a whole bunch of different algorithms researchers use for this, like proximal policy optimization or PPO.
PPO, okay. What's so special about PPO?
You can think of PPO as like a cautious optimizer. It's all about making small, careful adjustments to the LLM's policy, preventing those drastic changes that could throw off the learning process.
So instead of making these huge leaps that could mess things up, it's taking these small steps, constantly checking to make sure it's moving in the right direction.
Exactly. And that's one of the reasons it's so widely used. It's relatively stable and efficient.
Which is really important when you're dealing with these massive LLMs. Okay, so PPO helps fine-tune the LLM strategy using the reward model. But the paper also talks about this other interesting concept, test time scaling.
Ah, yes.
So what is that?
This is where things get really clever. Instead of just making the LLM bigger or training it longer, we can actually make it, think harder at the moment it needs to generate a response.
It's like giving the LLM access to this, boost of brain power, right?
Exactly.
I love it.
So one classic approach for this is beam search.
Beam search, okay.
Imagine you're exploring a maze, right? Instead of just picking one path at random and hoping to the best, beam search allows the LLM to explore several promising paths simultaneously. Increases the odds of finding the best solution.
So it's like giving the LLM the ability to multitask, to consider different options in parallel. What other techniques are there?
Another one is best of N search.
Best of N, okay.
It's like a talent show.
Yeah.
The LLM generates several different responses, and then a separate system, like a judge, picks the best one based on certain criteria.
So it's adding another layer of evaluation on top of the reward model, making sure the LLM is consistently putting out good stuff.
Exactly. And then there's self-consistency, which is a really interesting approach.
Okay, tell me about self-consistency.
Imagine you're trying to solve a puzzle. You try different strategies, and you look for the solution that comes up most often. Self-consistency, it's kind of like that. The LLM generates multiple reasoning paths, and it chooses the answer that appears most frequently.
So it's like the LLM is using its own knowledge to kind of cross-check its work and find the most consistent answer.
Exactly. It can be really effective for tasks involving, reasoning or problem solving.
Wow, this is so cool. It's like researchers are giving these LLMs a whole toolbox of strategies to become more effective thinkers.
It really is. And it doesn't stop there.
There's more.
Oh, yeah. There are even more advanced techniques being explored.
Okay, now I'm really intrigued. What's next? Give me the next level.
Oh, we'll have to save those for part 2.
You can't leave me hanging like that.
I promise it'll be worth the wait. All right, are you ready for those next level techniques?
Absolutely. Hit me with them. What's even more advanced than what we've been talking about?
Well, you know how we were discussing those limitations with fine-tuning and scaling? Well, some of these new approaches, they're really pushing the boundaries of how we think about LLMs and how they learn.
Okay, that sounds promising. Give me an example.
One that's really caught my eye is Tree of Thoughts, or TOTI for short.
Tree of thoughts. Okay, that sounds kind of philosophical. What's the idea behind that one?
It's actually more technical than philosophical. Remember how we talked about LLMs sometimes struggling with, staying focused, maintaining logical coherence, especially when they're dealing with longer pieces of text? Well, TT, it addresses that directly.
Okay, so how does it work? Does it actually involve, like, a tree structure?
It does. Instead of just generating text in a straight line, TOT lets the LLM create this tree-like structure where each branch represents a different possible line of reasoning, a potential solution path.
So it's like the LLM is brainstorming, exploring different avenues before settling on the best one.
Exactly. And here's the really cool part. The LLM can actually evaluate each of these branches, pruning away the less promising ones and focusing on the paths that seem most likely to lead to a good solution.
Wow, so it's like the LLM is doing its own quality control.
Yeah, making sure it doesn't waste time going down dead ends.
Brilliant. But doesn't that, that kind of branching thought process, doesn't it require a lot of computational power?
It can, yeah. TOTI is often more computationally expensive than those simpler methods like beam search. But the payoff is it can lead to much better reasoning, especially for tasks involving planning, problem solving, or creative thinking.
So it's like we're giving the LLM the extra brain power it needs to tackle those tougher challenges. The paper also mentioned another technique that builds on this idea, graph of thoughts, or GOT.
Oh yes, GOT.
What's the difference between TOTI and GOT? They both sound like, pretty complex ways of organizing thoughts.
So while TOTI creates that tree structure, GOT, it goes a step further and builds a graph. And this allows for more, I guess you could say, flexible connections between those different thoughts or ideas.
So instead of just branches, you can have loops, interconnections.
Right. And one of the big advantages of GOT is it lets the LLM revisit and revise previous thoughts, something that's more limited in that strict tree structure.
So it's like the LLM can go back and be like, wait a minute, maybe I made a mistake here. Let me rethink this.
Exactly. That ability to kind of iterate and refine its own thinking makes GOT really well suited for those really complex tasks, where the best solution might not be immediately obvious.
It's like the LLM is working through the problem step by step, but also has the freedom to backtrack and course correct if it needs to.
Yeah, it's really fascinating. And GOT also has some mechanisms for improving efficiency, like it can merge similar partial solutions, and that helps reduce those redundant computations.
So it's not just about making the LLM smarter, but also making it work smarter. I like it.
Right.
GOT really sounds like a game changer. Now, with all of these advancements, what are some of the challenges that researchers are still trying to overcome? It can't all be smooth sailing, right?
Of course not. There are always challenges, and this field is moving so quickly. One of the big ones is, that whole issue of catastrophic forgetting.
Catastrophic forgetting. That sounds, catastrophic. What does that mean?
Imagine you have this super smart LLM. It's learned a ton. But then you want to fine-tune it to be an expert in some specific area, like, writing legal documents.
Okay, yeah, so we want to give it a specialty.
As the LLM learns that new specialty, it can sometimes forget or lose some of that broader knowledge it had before.
But it's like its brain gets a bit overcrowded, some of the old information gets pushed out.
Yeah. It's a tough problem to solve. Even those clever PEFT methods we talked about earlier, like Loraya, they can't fully eliminate the risk.
So finding ways to prevent catastrophic forgetting, that's a top priority, right? How are researchers approaching that?
Well, one promising direction is developing better continual learning strategies where the LLM can learn new things without overwriting those old ones.
So it's like giving the LLM a better memory or a more organized, filing system for its knowledge.
A great analogy. Another approach is to use regularization techniques during the fine-tuning process so the LLM doesn't become too hyper-specialized in one area.
It's like reminding the LLM, hey, don't forget everything else you've learned.
Exactly. And then there's this whole area of incorporating external knowledge sources. So not just tweaking the LLM internally, but giving it access to more information.
So training it to use a knowledge base or even search engines to find information that's outside its original training data.
Yeah, that's right. Expand the LLM's knowledge without risking that catastrophic forgetting.
Yeah, we talked about those limitations of human feedback earlier. I imagine that's a big challenge too, especially when you need so much of it to train these huge models.
It's huge. Human feedback is subjective, and it can be very time-consuming and costly to collect at the scale we're talking about.
Yeah, it's like trying to get a room full of people to agree on the best ice cream flavor. Everyone has their own preferences.
Exactly. So researchers are exploring ways to use AI feedback to supplement or even replace those human evaluators.
AI feedback. So instead of asking humans to rate the LLM's responses, we would use another AI system to do the judging.
That's the idea. You can use a set of written principles to guide that AI model and then train it to, critique and refine its own responses.
So it's like having an AI ethics committee providing feedback to the LLM.
Right.
But wouldn't that risk introducing, the AI judge's own biases?
That's a really important point. Ensuring that AI judge is aligned with human values and doesn't, perpetuate harmful biases, that's a huge area of research right now.
It's like that saying, garbage in, garbage out. If the AI feedback is flawed, the LLM is going to learn the wrong things.
Exactly. So calibrating those AI feedback systems to human values and making sure there's that diversity of viewpoints, that's super important. Now, what about test time scaling? Any hurdles there too?
Yeah, test time scaling. We haven't talked about that as much. What are researchers grappling with there?
Well, one of the big ones is figuring out just how much computational power to allocate for any given query. We don't want the LLM to underthink and make mistakes, but we also don't want it to overthink and waste time and energy.
It's about finding that balance, right? Not too little thinking, not too much thinking, but just the right amount.
Exactly. And then there's the issue of reliability. We want to make sure that these fancy techniques for scaling up the LLM's thinking at test time, they don't introduce errors or inconsistencies into its output.
So it's not enough to just generate a bunch of responses. You have to make sure they're actually good.
Right. So developing robust verification mechanisms, that's another active area of research. Making sure that those test time scaling techniques are reliable, that's really important.
So lots of work still to be done, but it sounds like the field is moving forward at an incredible pace.
It really is. And there are some exciting new trends emerging.
Oh, like what? Give me a sneak peek.
Well, one of the biggest ones is this move towards hybrid approaches that combine pre-training with test time scaling.
So it's not an either, it's about finding the best of both worlds.
Right. Imagine you have a smaller base model that's pre-trained with some essential knowledge and then uses those test time scaling techniques to kind of dynamically enhance its responses when needed.
So it's like a lean, agile LLM that can access that extra brain power on demand.
Precisely. And another really exciting trend is the focus on privacy-preserving personalization.
Privacy, that's so important, especially as these LLMs become, more and more a part of our lives. What does that involve?
It's about customizing LLMs for individuals or for companies, but doing it in a way that doesn't put sensitive data at risk.
So it's like having an LLM that can learn my preferences, but without actually seeing all my personal information.
Exactly. And researchers are coming up with a lot of creative ways to do this.
That's amazing. It's great that privacy is being prioritized.
Absolutely. And then there's this trend towards multi-model systems. And this is really pushing the boundaries.
Okay, multi-model systems. What does that mean? I'm not familiar with that term.
So instead of having one giant LLM trying to do everything, imagine having multiple smaller, more specialized models that can work together, each contributing their own unique strengths.
So it's like having a team of expert LLMs collaborating on a project.
Exactly. And they can communicate, share their knowledge, and even learn from each other's, strengths and weaknesses.
Wow, that sounds like it could lead to some major breakthroughs.
It could. And then there's also all this research into multimodal RL integration, combining reinforcement learning with all sorts of data, not just text, but images, videos.
So it's not just about language anymore. It's about these LLMs interacting with the world in a much richer way.
Exactly.
This is blowing my mind. It feels like we're getting closer and closer to truly intelligent systems, ones that can learn and adapt in ways we never even imagined before.
It's an incredibly exciting time to be following all of this.
Yeah.
But as we get excited about all this potential, we also have to remember that there are some serious ethical and societal implications to consider too.
That's a really important point. We need to make sure these advancements benefit everyone, not just a select few.
Exactly. So, with that in mind, shall we move on to those cutting-edge techniques you were so eager to hear about?
Yes, please. I'm ready for even more LLM insights.
All right, so let's dive into some of those really cutting-edge techniques, the ones that are pushing the boundaries of LLM research even further.
I'm all ears. Hit me with them.
One that's generating a lot of buzz is called Tree of Thoughts, or 2T for short.
Yeah.
Remember how we were talking about LLM sometimes struggling to stay on track, maintain that logical coherence, especially with longer pieces of text?
Yeah, they can kind of go off on tangents sometimes.
You're right. Well, 2T, it tackles that head on.
Okay, I'm intrigued. How so?
Instead of just generating text in a straight line, 2T allows the LLM to create this, tree-like structure.
A tree. Okay.
Each branch represents a different line of reasoning, a potential solution path.
So it's like the LLM is brainstorming, exploring different avenues before settling on the best one.
You got it. And the really cool part is that the LLM can actually evaluate each of these branches.
Evaluate them how?
It can kind of prune away the less promising ones, and focus its energy on the paths that seem most likely to lead to a good solution.
So it's like it's doing its own quality control, making sure it doesn't waste time going down those dead ends.
Exactly.
This is brilliant. But I have to ask, doesn't this kind of branching thought process require a ton of computational power?
It can. 2T can be more computationally expensive than simpler methods like beam search. But the trade-off is that it often leads to much better reasoning, especially for tasks that involve planning, problem solving, creative thinking.
So you're giving the LLM more brain power to handle those really complex tasks?
I see. Now, the paper also mentioned this other technique that builds on this idea, graph of thoughts, or GOT.
Yes, GOT.
What's the difference between 2T and GOT? They both sound like pretty complex ways of organizing thoughts. So 2T creates that tree structure.
Right.
But GOT goes a step further. It builds a graph. And this allows for more flexible connections between those different thoughts or ideas.
So instead of just branches, you can have loops, interconnections, all that.
Exactly. And a key advantage here is that it lets the LLM go back and revisit those previous thoughts, something that's a bit more limited in that tree structure.
So it's like the LLM can go back and say, wait a minute, maybe I made a mistake earlier. Let me rethink this.
Exactly. And that ability to, iterate and refine its own thinking makes GOT especially well suited for those complex tasks where the best solution might not be immediately obvious.
It's like the LLM is working through a problem, but it also has that freedom to backtrack and course correct along the way.
Right, and GOT even has some built-in mechanisms for improving efficiency. Like, it can merge similar partial solutions, which helps reduce redundant computations.
So it's not just about making the LLM smarter, it's about making it work smarter, too.
Exactly. It's really quite remarkable what researchers are coming up with.
It is. So with all these advancements, it feels like the possibilities are endless. But, we have to ask, where do we go from here? What's the next frontier in LLM research?
Well, one thing that researchers are really excited about is this idea of combining all these different techniques, creating these hybrid approaches.
Hybrid approaches, okay.
So instead of just focusing on one technique, it's about finding the best combination of pre-training, fine-tuning, reinforcement learning, and all these advanced scaling techniques.
Yeah.
To really maximize the LLM's performance and capabilities.
So it's like creating the ultimate LLM training regimen.
Exactly. Another really exciting area is the development of even more sophisticated reward models. Ones that go beyond just basic accuracy and really capture the nuances of human preferences. Things like creativity, humor, and even empathy.
That's amazing. So we're not just training these LLMs to be smart. We're training them to be more, human.
In a way, yes. And then there's the whole area of integrating LLMs with other types of AI systems, combining them with computer vision, robotics, to create these truly intelligent agents that can perceive and interact with the world around them.
Wow. That's a whole other level of complexity.
It is. And then, of course, there's the ongoing work on addressing those ethical challenges, making sure these LLMs are fair, unbiased, and used in ways that benefit everyone, not just a select few. It's a huge task, but it's absolutely crucial.
I completely agree. Well, this has been an incredible deep dive. I feel like I've learned so much about the inner workings of LLMs, the incredible advancements that are being made, and the challenges and opportunities that lie ahead.
I'm glad you found it valuable. And remember, this field is moving so quickly. New discoveries and breakthroughs are happening all the time. It's really an exciting time to be following LLM research.
It is. And thanks to you, our listeners can stay up to date on all the latest developments. So thanks for sharing your expertise with us today.
My pleasure. It's been a great conversation. And to everyone listening, keep exploring. The world of LLMs is just getting started.
And that's it for this deep dive. We'll see you next time for another fascinating exploration of the world of AI.